All right, guys, welcome to this page of the notes. And again, what we're doing here is we are solving inequalities that contain radicals, and we got to do it in 2 steps. We've already done one of these together, so we'll go through this one a little bit quicker. Remember, step 1, we need to eliminate or exclude any imaginary solutions. I do that by setting the radicand, what's under the radical, greater than or equal to 0. What that'll do is that will ensure that what is underneath the radical stays positive. If this were ever negative, then you would wind up with an imaginary number, and I don't want imaginary numbers in my solution set. So we set the radicand greater than or equal to 0. That means we'll always be taking the square root of positive numbers, and we're good. So that means that I have 2x is greater than or equal to a negative 2. Divide both sides by 2, and I get x is greater than or equal to a negative 1. So what this tells me is I need values for x that are bigger or equal to a negative 1. If it were less than a negative 1, I would wind up with an imaginary number, and I don't want those. Step 2, oh, sorry, I forgot to write it. This is step number 1. Step number 2. Step number 2 is to actually solve the inequality that you've been given. So we have the square root of 2x plus 2 plus 1 is greater than or equal to 5. Well, I need to get rid of the radical, which means I'm going to raise both sides to a power equal to the index. But before I can do that, I need that radical to be by itself. That means I got to get rid of the 1, which I'll subtract to the other side. And 5 minus 1 is 4. Now, in order to get rid of the square root, we raise both sides to a power equal to the index, which in this case is going to be a 2. And I do it to both sides because algebra says whatever you do to one side, you got to do to both sides. Index and the power are the same, and so we have 2x plus 2 is greater than or equal to a 4 squared, which would be 16. Subtract the 2 to the other side, 2x greater than or equal to 16 minus 2 is going to be a 14. And then I divide both sides by 2, so x needs to be greater than or equal to a 7. Needs to be greater than or equal to 7. All right, let's go ahead and take a look at the number line and find out what's going on here. This one is actually really interesting. There's my 0, negative 1, negative 2, negative 3. Nope, what on earth am I doing? Sorry about that. That's going to be a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's far enough. Okay, here's what we've got. Step 1 tells me I need all values of x greater than or equal to a negative 1. Everything greater than or equal to a negative 1. But step number 2 tells me that the values of x need to be greater than or equal to a 7. Well, who wins? Obviously, the one that wins is going to be whichever one is bigger. Since this one tells me everybody bigger than a negative 1, but step number 2 tells me, now actually it's got to be everybody bigger than a positive 7. That one wins. Close circle on 7, and we go in this direction. Now, why? Well, here's the reason why. Based on step 1, if everything needed to be greater than or equal to a negative 1, that means that 0 would be a solution. However, if you plug 0 into the original problem, you get something that is less than 5. And the original problem says it needs to be greater than 5. In fact, anything between negative 1 and 7, right? Any of these values, 0, 1, 2, 3, 4, 5, 6, all those values, if you plug them in, is going to give you something that is less than 5. And they don't satisfy the actual inequality. Yes, they give you a positive number under the radical, which is awesome, but they fail to satisfy the overall inequality. The only way we satisfy both things, a positive number under the radical and we get something bigger than 5, is if we choose values of x greater than or equal to 7. And so your answer is going to be x greater than or equal to 7. We don't really need to worry about the first step in this particular example problem. Guys, I have one more for you. Head on over to the next page of the notes. We'll take a look at that one. I'll meet you guys there.